I want to show you how to use Desmos and its graphing calculator to calculate the value of a limit of a complex function. And specifically, I want to show you how to use Desmos in general to how to enter in a function and then look at the behavior of the graphical representation, how the graph looks. So here's one of the potential questions you would have for, I think this is homework 2.2. For one of your homework assignments here. And so we're trying to see what happens to this complex looking function, whatever it looks like, right? Whatever it represents, find its limit as the values, the x values get closer and closer to 0. And that's what's represented here on this table. So what we want to do is take this function and then on Desmos graphing calculator, I think it's 8x and 7x. And so when you type that in, right, f of x equals, and then again, it's real simple to put that in using the division symbols and typing it as it looks. We end up with this equation here. And so what happens, one thing I want you to realize, and again, I wish you had more time to really focus on it, that you see the graph over here, this function right here. And so it has a very interesting looking behavior because of the dynamics of this function here. So you can see it oscillates up and down, and it comes way down. And so what we're really interested in is what happens as you can see. I'm going to zoom in a little bit more. As you see what happens as I trace along, you can see the values as you click on it. As I'm getting closer, right, my point is approaching, getting close to when x equals 0. And I can see somewhere here what happens is, because if you substitute 0 into there, right, if I plug in, here's an issue, right? I can plug in f of 0. When I plug that in, it's undefined, right? Because you can't divide by 0. And if I plug in numbers that are really close to 0, like 0.1, we see a value, negative 6.8. What's another like close or approaching, right? How about that? Negative 7.4. So you can see as I get close to it, I have these values. I still get a value, but when I'm at 0, it's undefined. So that leads us back to, again, the behavior of the graph over here. As I get closer and closer, you can see it seems to approach some value. So another way to do that is once you have the function, you can plug in values like this. Or you can, let me erase some of this stuff here. I don't need to, but I'm going to erase it. You can hit this gear function and you get an option of making a table, convert that to a table. And then once you do it, there it is, it comes in. And you can see the various points from the table. Now, I want to get very close to this here. So you have 0.2, 0.1. So I can mimic that, or I can repeat that. And so these are the answers, right? You have a different problem. But you can see what happens. It seems to get closer and closer to some value. So I could plug in the numbers, negative 2, negative 1, negative 0.1, right? Negative 0.001, negative 0.001, right? And you can see it starts to get close to 7. And you can also do it from the other side too if you want, like 0.0001, right? And so it looks like it's having a limit of negative 7.49, that it gets really close. But I can see that in the graph also. And it looks like, again, I clicked on a point there, 0. So it looks like it's approaching, right, that value, like negative 7.5, 7.49. And so you can see it looks like it's getting closer and closer to that. Doesn't equal, remember, a limit. What happens to the function as x approaches 0, right? The function approaches negative 7.5. And I can see that in here. But again, you'd use the gear, or again, you could type in actually f of, and then plug the number in, 0.0001, right? And you can see what we're getting there as you continue to get closer and closer to 0. What happens, right? You're getting, did I do that right? There it is. Make sure I type that in right there, right? As you get in there, you can see you get certain values. But weird things happen as you get smaller and smaller and smaller in there, right? It approaches this value. So that's how you would use Desmos to do that.